Hello and welcome to Chapter 5, Section 5. In this section, we're going to learn both the midpoint and the distance formulas for line segments that you're graphing. The midpoint is defined as the point that divides a line segment equally in half, where capital M, and I'm going to write it like this from now on so you can tell the difference. Capital M is our midpoint, and our endpoints are xy1 and xy2. Our midpoint formula is capital M equals x1 plus x2 divided by 2 and y1, y2 divided by 2. We're actually finding the average of the two x's and the average of the two y's to get the one point in the middle of both of those. So now we're going to try it together. We're going to try with 2 points to find the midpoint. So I'm going to say capital M equals -2 plus 4 over 2 and -1 plus 2 over 2. That's our midpoint. So we know that this equals x and this equals y. And now it's just a matter of doing the math. -2 plus 4 is 2 over 2, and -1 plus 2 is 1 over 2. So our midpoint actually equals 1, 1/2. And that's it. Give that a try for check it out number 1 on the bottom of 330, and pause the video here and come back when you're done. So our first check it out. Given these 2 points, we plug them into the midpoint formula, and our midpoint is 3/2, 0. The next thing it's going to ask us to do is when you are given one endpoint and the midpoint, can you find the other endpoint? And it tells us what the midpoint is and what A is, and it asks us to find B. We're going to have to work this backwards. We know that our midpoint is 4, -3, so we're going to actually write it this way. 4, -3 equals 2 plus x over 2 and 2 plus y over 2. So we've got the A point, and we're looking for the B point. Now, we know that this one equals x and this one equals y, so we're going to separate them. The answer to this problem is going to give us 4. So we're going to separate 4 equals 2 plus x over 2, and then this is going to be y. -3 equals 2 plus y over 2, and we can solve these. Now, when you have a complex fraction like this, the first thing we're going to do is multiply both sides by that denominator to get rid of it. So these go away, and we end up with 2 plus x equals 8. 2 plus y equals -6. And now I'm going to subtract 2 to get x equals 6. And I'm going to subtract 2 to get y equals -8. And so now this is my B point, 6, -8. And now I have to go graph this, where my A is going to be 2, 2, and my midpoint is 4, -3, and my answer is 6, -8. And hopefully they all end up in a line with your midpoint halfway between the first one and the second one. Okay? Try this yourself on check it out number 2, page 331. Pause the video here and come back when you're done. For check it out number 2, we're going to take our x out and say it's equal to the average of the two x's, and our y is going to be equal to the average of the two y's. And again, we're going to multiply both sides by 2 to get rid of this denominator. So -2 equals -6 plus x and 2 equals -1 plus y. And we're going to add 1 to both sides. We're going to add 6 to both sides. And our answer ends up being 4, 3. And it just asks to find the coordinate. The next thing we're going to work on is the distance formula. And this tells you the distance between 2 points. Now what I want to remind you of is when you've studied the Pythagorean theorem that told you that in order to find the length of the hypotenuse, you added the squares of both legs of a right triangle. So you ended up with a squared plus b squared equals c squared. This is why Pythagoras came up with that, so that he could find the distance of a line segment, the distance between any 2 points on a coordinate plane. So here's what that looks like. A is the change in x. It's the change from this point to this point in x. B is the change in y, the difference between this point and this point on the y-axis. If we start with a squared plus b squared equals c squared, and we know that c equals the square root of a squared plus b squared, let's start with that one. C equals the square root of a squared plus b squared. Well, a squared, a is the change in x. So a is x2 minus x1, the change in x squared, plus b, which is the change in y squared. This is the distance formula. Now, they don't call it C, they call it D because D is for distance. But this is what they're looking for when they give you 2 points. So what does that look like when you're given the problem and you're asked to find the distance between point A and point B, and you're given these 2 things? The first thing you're going to do is write down that distance formula, the square root of the change in x, x2 minus x1 squared, plus the change in y, y2 minus y1 squared. And then you plug in your lots. The square root of 2 minus -2 squared plus -2 minus 3 squared. The change in x minus the change in y. 2 minus negative, dink dink, 2 plus 2 is 4 squared plus, and -2 and -3 is -5 squared. 4 squared is 16. -5 times -5 is a positive 25. 16 plus 25 is 41, and then you get your calculator, and the square root of 41 is about 6.4. And they want it to the nearest hundredth, and they don't tell you that to the end. So what I really need you to do is track this, because with all of these calculations, it's super easy to make a mistake. I want to see all of these steps. I don't make mistakes because I can see what I'm doing, and if I do make mistakes, I can go back and see where I messed up. Then they've got a word problem. Our word problem, each unit on the map of Lake Okeechobee represents 1 mile. Delia and her father plan to travel from point A near the town to point B at Pahokee. And these are the coordinates on this map. And the question is, how far across the lake are they going to travel? So we're going to plug those right into our distance formula. x2 minus x1 is 33 minus 22 squared plus y2 minus y1 is 13 minus 39 squared. This is 11 squared plus, and this is negative 26 squared, which is negative 26 squared, which is going to give us 121 plus 676, which is the square root of 797, which is about 28.2 miles. That's everything you need for section 5 of chapter 5. Pause the video here so you can check it out numbers 3 and 4 on page 332 and come back when you're ready. Check it out number 3. We're going to plug 3, 2, and negative 3, negative 1 into our distance formula. And we're going to end up with the square root of 45, which is about 6.7. And then for number 4, from Pahokee to Clewiston, we're going to plug those points in, and we're going to get to about 17.7 miles. All right? Your homework tonight starts on page 333, numbers 11 to 27. Please ask me if you have any questions, and I will see you next time.